Hi, my name is Obaidur Rahman and I am a data scientist. In this video, I'm going to show you how you can use NLAVIDA, which stands for Natural Language Assisted Visualization and Interactive Data Analysis, to work with multiple files. Let's first talk about the benefit of using this code. Why should you use this code instead of anything else? There are three C's of reasons for that. The first one is confidentiality. You can work with your files that are confidential, and you will not have to upload these files to any service providers. So all your confidential data, internal secret data, remains within premise. You do not have to worry about privacy. The second C is customizability. This is completely open source. So you are able to see the source code, and you can start with that and build on top of it. If you have a problem that you are trying to solve, you are trying to build an in-house solution, you can start with this and build your full-fledged in-house solution. The third one is cost. Right now, you can use it with an API to a large language model. So you only pay for how much you are using the large language model. You do not have to buy subscriptions to any service providers. So you can scale it according to your need. Okay, so we can work with any files, but I'm going to give you an example here with some synthetic data. So I have created some dummy files, you can say, and I'm going to show them to you. So this data correspond to a chemical sales data. Let's say there is a chemical industry and it has sales data. So here I am opening the file t.csv. T stands for transaction. So as you can see, there are several columns here, and each row corresponds to a particular cell. So the first column is date. So on this date, 1st January 2023, this is the amount of the chemical that was sold. So 52 tons, and this is the price in US dollars. And this is the total sales price. So you multiply this column with this one and you get this. So this is the total amount of money that was involved in that sale of a particular chemical. So I'm not giving the name of the chemical here, and also I'm not giving some other details. Instead of that, they are encoded. So look at this column, for example, region code. So region code corresponds to a particular continent, but I'm not telling it which continent it is. So instead of that, I'm giving it a code like R2. Similarly, there could be different products. It could be different chemicals, basically. It could be benzene, acetone, whatever. And this is also encoded. And then you have customers. So there could be different type of customers that might be buying these chemicals. It could be agricultural industry, pharmaceutical, or others. So this kind of simulates a real world transaction. So where you don't have all the details in one table. So this table corresponds to each of the transactions with some of them written in codes. Now we can close this one. Let's open this one. C stands for customers. So here you have the information about what these codes mean. So all these codes that are written in customer section, they are explained here. So C1 means pharmaceutical, C2 means chemical, and so on. Similarly, you can take a look at the product table where P1, P2, P3, P4, they are explained what they mean in terms of actual chemicals. Now, to be able to make sense of the transaction, you'll have to join these tables together. So actually large language models can handle that, and NLAVIDA can handle that. It can take information from different files, join these files using Python code, and produce meaningful results. But to simulate the real world, what I have done here, I have created a metadata file. So it is typically the case that you have a bunch of files like that, like T, C, P, R, and then you have a file called metadata. So I have named it as metadata.csv. And please note that to use NLAVIDA, you'll have to name this file metadata.csv. That's how I have given it instruction to look for a file called metadata.csv. Now this file, let's take a look what it means. how it is structured. So there are, this column you can ignore. So there are 3 columns mainly: column name, table name, and description. So I have shown you 4 tables here, right? T, C, P, and R. So these are the tables. So as you have seen already, the table T has multiple columns like date, quantity sold, unit price, and so on. And this description is an explanation of each of the columns. So the date column in table T has transaction date. The quantity sold tons column in table T has amount of product sold in tons. Similarly, the other columns in each of these tables are explained here. Now here is the challenge. Can we use NLAVIDA to open this metadata file and try to understand which tables have which columns and what kind of data is stored in each of these columns? And from that knowledge, is it able to open these files and then join the tables together, like it converts the file into a table first, and then is it able to join these tables in a meaningful way to get the result that you want? So let's take a look how it works. So first we need to upload the files. So let's upload the file c.csv. Now in the previous video I have shown you that it is nice to give some description here. So it says file uploaded successfully, would you like to briefly describe its content to me? So if you give this information, this is kind of metadata, right? So if you give this information to the LLM, it has a better understanding of what that file contains. But in this case, we are not going to give it any information. We want the LLM to open this metadata file and then interpret what is there in the other files. So I'm just going to leave it blank and submit. Similarly, let's upload the other files. The next one could be metadata. Again, no description, just submit. Next one is P for products, submit. Next one R for region, submit. And then T for transaction, submit. Now all the files are uploaded, including the metadata file, and we have not given it any text, any information about what those files contain. Now we are going to ask it some questions. But before we do that, let me quickly show you what is behind this NLAVIDA. Just an overview, like a blueprint. So here how it looks like. So there are some agents inside NLAVIDA. So what are agents? Agents are, you can think of them as function. They are powered by large language models and they can work with natural languages. So a user can ask a question to the so-called grand agent. This is the coordinating agent. It can have multiple agents underneath it. At this moment we have only one agent, which is called a Python agent. Now when the user sends the question in natural language text to the grand agent tries to understand the question. Depending on what it is asking, what the user is asking, the grand agent decides what to do with it, what to do next. So it can have multiple agents. In this case, it has only one agent. So it sends a query to the Python agent based on the question that the user has asked. Then the Python agent has the ability to write Python codes. So depending on what the grand agent sent the Python agent, it interprets it and it writes the right Python code that is needed to answer the question. And then it sends this Python code to something called Python REPL. Python REPL, you can also think of it as a function. It has the ability to take any Python code and execute it. It can execute any Python code. It can also make plots for visualization and so on. If a plot is made, the link to the plot is sent back to the front end so that the user can see it. Now that all the files are uploaded, let's make it a little bit bigger. We can ask questions. So something of interest could be to look at the sales trend of a particular region for a particular chemical perhaps. So we can ask a question like this: what is the monthly sales trend of any chemicals, let's say here acetone, in a particular region, we can say Europe, and ask NLAVIDA. Now I'm going to show you quickly what's happening behind the scene. So the grant agent is sending a Python agent this text: analyze the monthly sales trend of acetone in Europe using files c.csv, p.csv, r.csv, and t.csv. Use metadata.csv to understand the structure of these files. This is exactly what I wanted it to do. And then the Python agent decides a strategy. To analyze the monthly sales trend of acetone in Europe, I need to follow these steps. So load the metadata file, identify relevant columns and relationships between the files, extract necessary data to acetone sales in Europe, aggregate the data on a monthly basis, then generate a plot. So then the Python agent creates Python codes, right? It imports certain packages and opens a file, in this case metadata file. So it has opened the metadata file and it looks at this structure and it tries to understand what is the structure. Then to analyze the monthly sales trend of acetone in Europe, we need to load the t.csv, r.csv, and p.csv files. And then after opening these files, it does some operations, it joins them, it first puts them into some tables or pandas data frame called transactions, regions, and products, and then eventually joins them to get the final result. Finally, it generates a plot to visualize. So yeah, here is the plot that is happening. All right, let's go back to the front end and see what we have here. All right, so it says the monthly sales trend of acetone in Europe has been analyzed and visualized. The resulting trend has been saved as a SVG file named this. You can view this file to understand the sales trend over the month. So here we have it. In 2023, from January to December, what is the total sales in US dollars? Yeah, month to month. Very nice. So you can take the code. I will share the link at the bottom. You can clone the repository and use your own files and do analysis and visualization and let me know what you find out. It can work with any type of data. So you can give me feedback or you can contribute or you can interact with me with 3 C's. The first one is comment. I'd very much like to know how you find this code. If you have any trouble, if you have any questions, if you have any suggestions, please make comments. Second C is contribute. This is just the starting point. I think that this has the potential to become a very, very useful tool, but it needs a lot of work. I'm going to continue working on this, but if you also would like to contribute to this open source project, please do so. I'll be very thankful for that, and the whole community will be thankful for that. And the third C is collaborate. If you have an idea that you want to take this code and develop into something that will solve some of your problems, and if you want to work with me, I'd be very happy to collaborate as well. Thank you very much for watching. All the best.